Okay, so this week I'm going to try and cover quite a lot of material. I'm going to go for all of the sort of, well, a quick summary of all of the statistical measures, concentrating on averages and range from grouped data, comparing distributions, and quickly just going over some statistical diagrams. And then also, hopefully, we'll have time to have a look at probability, including some Venn and tree diagrams. We may not get through all of it, and we might need to push some to next session, so that's okay if we do. I'm just going to talk through it quite quickly. So I've got my chat open up here. That's why I'm looking up. So do just write in the chat if you've got any questions or if you want to stop me or if I'm going too quickly. Okay, so averages then. Just a quick reminder, there's 3 types of averages. I'm sure you know what they are. We have the mean, which we find the mean by adding up all the data and then dividing by how many bits of data there are. Median is the middle one, okay? So put them in order first and pick the middle value. Very common in an exam for a student to forget to put them in order just because they're rushing a little bit on these questions. Do remember, it needs to be in order before you pick that middle value. And then the mode, which is the most common bit of data. So those are the 3 types of averages. We'll do a bit more work on those in a minute. Range is not a type of average. You always hear about mean, median, mode, and range. Range is actually not an average. It's actually a measure of spread, okay? So it's calculated by subtracting the smallest bit of data from the largest bit. Nice and easy to calculate, but it doesn't actually tell us anything about the average. It tells us how close together the data is or how consistent it is. So it's a really useful bit of data, a really useful statistic to calculate, but it's not actually an average. A lot of people might say it is, it's not. Okay, so typically you might be given a set of numbers, especially if you're doing the foundation paper. You might be given a set of numbers like this, and then asked to find the mean, median, mode, and range, okay? So you should know how to find those 4 things. So a quick reminder, the mean is we add them all up and divide by how many there are. So there are 10 bits of data, okay? Adding them all up, I'm not going to ask you to do it. I'm just going to sort of go through the how to today. So adding them all up, you get 50, dividing by how many there are. So dividing by 10, with 50 divided by 10 is 5. The next one, median. So the median is the middle number. So before we just take the middle number, we can't just go to the middle number right now because they're not in order. So we're going to need to put these numbers in order first. So you can see I've ordered them first, then you can find the middle number. Now I've chosen this set because there's 10 bits of data. So when there's an even number, we actually have 2 numbers in the middle. So to get that median value, we have to find the middle of the middle, which is kind of the mean of the middle, I suppose. Oh, sorry. So the middle of the middle there is 5.5 or 5.5. The mode is the most common number. So we're looking now, looking at them we've already put them in order. We can see that 5 comes up twice, but 6 comes up 3 times. So 6 is the mode. So it's a really simple one just to have a quick look at. And then finally, range. Well, range is the biggest number, take away the smallest number. So it's going to be 9 minus 1, which is 8. If you do have any questions, please do pop them in the chat. Otherwise, I'm going to assume this is kind of just a revision. So I'll go straight on to some more challenging stuff. The most common thing you're going to be working with is the mean, especially if you're doing a higher paper. So this is a question using the mean, but for higher paper, okay? So we've got a basketball team and they're playing lots of games of basketball. And they're adding up all of their points that they make per game. And then they obviously dividing them and finding the mean. So they've divided it by 10. So at the end of 10 games, their mean score is 35 points per game, okay? But at the end of 11 games, their mean score has gone down to 33 points per game. So we kind of know already that 11th game didn't go so well for them, okay? They've obviously not got as many points as they usually get because their mean has gone down. So we're expecting it to be a low number. But how are we going to find this number? Well, using this information first, at the end of 10 games, their mean score is 35 points per game. How do we calculate the mean? Just find my pen a second. There we go. So the mean, remember, is add them all up. So I'm going to put T for like the total number of points. That's all of the points they've got in all of the 10 games, divided by the number of games they've played. So what do we know here? Well, we know that the mean is 30, so we can put 35 in. We don't actually know. They haven't given us the total score. They haven't told us anything apart from the mean and the number of games. So we don't know the total score at the moment, but we do know that they have played 10 games. So using this formula, this little equation, we can solve it. We can say, well, if 35 is equal to the total score divided by 10, then the total score must be 35 times 10. So that's 350. So we don't need to know the individual games. We don't need to know how many points they've got in the individual games, because what we do need to know is just how many they've got overall. So that's 350. So in the first 10 games, they've got 350. So that was the kind of using that first bit of information. Now we need to look at this information. At the end of 11 games, their mean has gone down to 33. So after 10 games, they had 350. So this 11th game is obviously going to be some more points, and that's what we need to find. I'm going to call that X because that's the value we're actually looking for in this particular question. And now they haven't played 10 games. 350 was 10 games, plus the points for the extra game. That's going to be the 11th game. So they've played 11 games, and that's going to be equal to the new mean. And the new mean is 33. Okay. So we've got a kind of a new equation now that we have to solve. So a little bit more complicated, two-step equation this time. So now we can solve it in two parts. 350 plus X is going to be, multiplying up, 33 times 11. I'm going to calculate right now is 363. And then X, that number that we don't know, is going to be found by just subtracting that 350 from both sides. So 363 minus 350 is going to be 13. And again, just go back to the question and check, does this make sense? And it does make sense because it's quite a low number. If their average score is 35, we wanted a number that's less than that because the mean has gone down. If the mean had gone up and we got a number less than 35, it wouldn't make sense. Okay, so we kind of need to check, does this make sense? And yes, I would say it does. Does anyone have any questions after that? Or shall I move straight on? Understand? Great, thank you. Okay, let's move on then. Okay. So another type of range is the interquartile range. So the interquartile range is a little bit more useful in types of data where we've got something called outliers, which is maybe having like a really small bit of data or a really big bit of data, and it can just skew the data a little bit. So to calculate the interquartile range, we need to find the two quartiles. The upper quartile, which is 3/4 of the way up through the data, and the lower quartile, which is 1/4 of the way. So we technically have 4 quartiles actually. We have, we call them Q1, Q2, Q3, and we don't really ever use Q4 because that would just be all the way through the data. But the Q1 is the lower quartile, Q2 is the median, it's 50% of the way through, Q3 is the upper quartile, and Q4 is just all of the data. Okay, so we don't worry about that one. So to find the quartiles, the easiest way to do it is just to find the median first, and then to find kind of the median of the lower section and the median of the upper section. So let's see that in action. Let's have a look. The median is right in the middle. So of 15, The median is going to be that sort of 8th number there, where we've got 7 below and 7 above. And then once we found the median, we can take those numbers, those 7 numbers below, and we can find the middle of them, or the median of those. And the middle of those obviously is going to be this number 18 here. That's our lower quartile. And then our upper quartile is going to be the middle of the upper ones. So we've got an upper quartile of 35 and a lower quartile of 18. And the interquartile range is the upper quartile minus the lower quartile. So it's 35 minus 18, which is 17 there. Okay. So one thing I didn't actually write down there, just in case you were taking notes. The interquartile range is the upper quartile minus the lower quartile. That's quite an important bit of information. Okay. All right. Okay, so averages in higher tier especially, we don't tend to find averages from just number, like just data with numbers. We tend to use averages or find averages more from frequency tables. So a frequency table shows us what data is being collected when there's kind of quite a lot of data. So we wouldn't want just a list of numbers, because we'd end up with a list of like 50 numbers or something, and can't do much with that. So looking at this, okay, we've got the number of people living in a house, and then how many houses have that number of people in, okay? So we can see here that we've got 4 houses with 1 person living in it. Here we've got 4 people, and we've got 9 houses with 4 people living in them, okay? So hopefully that makes sense. There we've got 7 houses and with 3 people living. So it's just data that's being collected and then sort of tallied into a frequency table. So if we're going to calculate averages from a frequency table, we need to, think about what we would have here. So if I was going to get the mean, I would have like 4 ones, 1, 2, 3, 4, and then I would have 6 twos and so on. I'm not going to write them all out because it will take me forever, but you kind of see what's going on there. So I've got all these numbers, and if I wanted to find the mean, I would have to add them all up. So I do 1 plus 1 plus 1 plus 1 plus 2 plus 2. But of course, it's much quicker to just do 1 times 4 and 2 times 6. There are 6 twos there, so 2 times 6. And 3, well, there are 7 threes when I've written them all out, so it would be 3 times 7. So what we do is we just multiply the number of people living in a house, or the number of like whatever it is we're working, by the frequency, and then add those together. And it's just a cheap, quick way of kind of doing this, adding all these ones separately, adding all these twos separately. It just speeds up that process and makes it much quicker. So to find the mean, I think that it was going to come up, so I can just put that up there now, hopefully. Yeah, there we go. So to find the mean, you just do the number of whatever's in this table. So in this case, people living in a house, multiplied by the frequency for that particular group, and then add the next one, and add the next one, and add the next one, and add the next one. So you multiply them all together and then add them up. Then divide it by the total. So you're going to have to work out 4 plus 6 plus 7 plus 9 plus 4. That's the total number of people like that were surveyed. Okay. So that 30 is just this total here of adding these numbers up here. Okay. And then once we've worked that out, we've got 93 divided by 30 is 3.1. And always go back and double check. That's the mean number of people living in a house. I know it seems crazy because you can't have 3.1 people, but when we're working with averages, those kind of things don't matter. So looking back here, 3.1, yeah, it's pretty much in the middle. Looks about right to me. So yes, I'd say that's a really good estimate, or really good value. If we'd got an answer here of 7, well, it's definitely not 7, because 7 isn't even within the range of values. Okay, so always check, does my answer make sense? Is it in those values? Median. So the median, we know that we have got 30 people. We've already done this. We've added this up. So this was equal to 30. So the median person is going to be the 15th person. So again, if I had all those written out, 1, 1, 1, 1, 2, 2, 2, 2, I could just count all the way up to, it would actually be the 15.5, like the halfway between the 15th and the 16th person. So there would be a number. This is my first, second, third, fourth, fifth. Somewhere up here, there would be a 15th number and a 16th number. And whatever those numbers are, I need to figure out what the middle of them are. So I can do that now by just adding as I go along. So 4 plus 6 is 10. 10 plus 7 is 17. So I know that my 15th number is going to be, I've got 4 ones, I've got 6 twos, and then the next ones are threes. So I know this 15th number and this 16th number are both going to be threes. So my middle, my halfway between them is a 3. Okay, so hopefully that makes sense. Do let me know if you want me to go through that again, because it's a bit tricky. Lost my mouse a second, moving on. Okay, so 30 bits of data. The value between the 15th and 16th value is a 3. Okay, it lies in that 3 group. The mode is always nice and easy. It's a really easy one from frequency tables because we're just looking for the highest frequency. If I was to list all these numbers out, I would have 9 4s. So 4 would be my mode. Just be really careful. It's very common in exams. Students will write down this number instead of this number. Again, it's just that kind of rushing in an exam thing that students tend to do. So just be really careful. You're looking for the highest frequency. So you're looking for the highest number out of these, which is this one, but the actual number that it's representing is the 4, and that's the answer. Okay, so just be super careful not to make that mistake. And then finally, the range. So we've got the smallest number of people living in a house is 1. The biggest number of people living in a house is 5. So 5 minus 1 is 4. Okay. Right. Let's clear those drawings. Okay. So that's tables, but that's not grouped. So there's just numbers here, 1, 2, 3, 4, 5. So quite often, and this is definitely, I think group data, finding averages is higher tier only. So this could come up in foundation, but higher tier only with group data. I'm pretty sure I might just get someone to maybe just double check that actually if you are doing foundation. So group data obviously is where we've got huge amounts of data, and it wouldn't make sense if we were collecting information on people's heights and we'd have, everyone's heights are a little bit different. They're not all going to be fitting into nice categories. So instead of just giving numbers, we tend to give groups, okay? So the questions that we do get asked in group data are modal group, which is just the mode. So the group with the most data, it's just the group that is the mode, and the estimated mean, okay? So why do we estimate the mean? Well, when we have grouped data, we don't actually know what the individual values are. So if I take someone's height and that's 172 centimeters, that height might go into the group 170 to 175. So I've lost the actual bit of data that said it was 172. So then when I want to go and find the mean, I don't actually know what the original number was. I just know it was somewhere between 170 and 175. So my mean will not be exact. It will be an estimate. So that's why it's called estimated mean. Okay. So what we do is we assume that each bit of data is in the middle of the group, and then they kind of even each other out. So if we just say, well, every bit is right in the middle, then we tend to get a good, the best estimate we can get. Okay, so let's have a look. This is how long it takes people to get to work. So again, wouldn't really make sense to write down and tally like everyone's individual numbers, because we'll have numbers ranging from 2 minutes to 49 minutes, and there'll just be a lot of data there. So instead, we'll put them in groups, and then we've got frequencies. And like we said, to find the estimate of the mean, we'll be looking and just assuming that everybody's time is exactly in the middle of their group. So we need to find the midpoint of each group. Okay. Oh, sorry, I missed the modal group first. So the modal group is the one with the largest frequency. Really easy. Look along the numbers, find the one with the biggest number. The number is 12. So the modal group is this. Again, this is always a 1 mark question in exams, pops up quite a lot. Remember, if you write 12, you get no marks. Okay, you must write down the name, the number, like the group. So you must write down 20 is less than or equal to the time, which is less than 30. You must write this down, copy it exactly. Okay, so just be really careful with that. So now finding the mean. Okay, so to find the mean, we'll need to find the midpoint of each group first. So the midpoint of this group, 0 to 10, is going to be 5. The midpoint of this group, 10 to 20, is 15, and then 25, 35, and 45. So you've got 1 mark there just for finding the middle of each group. Next, we're going to assume that each person is exactly on that midpoint. So we're saying, well, 5 people take 5 minutes, 7 people take 15 minutes, 12 people take 25 minutes, and so on. And now we go ahead and we calculate the mean just in the same way that we did with the last table. So it's going to be 5 times 5, so plus 7 times 15, and so on. So just do that calculation. Do make sure in an exam you write all of this down. You get marks, but you also must write it down. Very easy to make a quick error. If you just type it in your calculator and you've made a little error, but you've not written anything down, you get no marks because the examiner can't see what you typed in. And if you made one small error, then it's completely lost. Okay, so just write it all down. 5 times 5 plus, 7 times 15 plus, 12 times 25 plus, 4 times 35 plus 2 times, so you're just timesing them. But again, it might even make sense to write in the individual numbers here. 25, whatever 7 times 15 is, whatever 12 times. So write them all in, okay? Just to kind of make it a little bit easier when you're working in the calculator. And then divide by the total number of people. So again, the total number of people is the total frequency. 5 plus 7 plus 12 plus 4 plus 2. Gosh, I've talked a lot, but we've got through quite a lot. Does anyone have any questions on this? Sorry, I've gone so fast. Okay. Right, so here is a task. I'm going to give you just a couple of minutes to have a go at the task. So you're going to find the modal group and an estimate for the mean, and you're going to pop it in the chat. Oh, good question. Why is it divided by 30? So to find the mean is always add them all together. So kind of the total divided by the number that there are. So here, what we've got is we've got people and how long they're taking to get to work. So this is the number of people, the frequency. So 5 plus 7 plus 12 plus 4 plus 2, I hope equals 30. 4 and 2 is 8, 12 and 8. Oh, it's not, is it? Is that my mistake then? Sorry, that's a really good question because I think that it's not actually right. Oh no, 5 plus 7 plus 12 plus 4 plus 2 is 30. Okay, so that is okay. Yeah, 6, 12, 18. Yeah, no, so yeah, it's just the total frequency. Okay, all right, great. Any other questions? Okay, I'm just going to give you a couple of minutes then because I've talked at you a lot and you've not actually had much chance to do any maths. You will probably need a calculator for this question. So hopefully you've got one nearby. If not, at least you can do the modal group without a calculator. And then estimate the mean. You can at least get what you would type into your calculator written down. So hopefully you've got one with you though. Anyone going to type in the modal group for me into the chat? Should be a really quick one. Should be able to get that just very quickly. It's always a 1 mark question, the modal group. Yeah, correct. Well done. Yeah, sorry, it's not the easiest to type in all those symbols, but yes, it is the one, the first group there with the frequency 7. So modal group is 0 to 5. With the estimated mean, do you have calculators? Are you able to do it now? Or would you prefer me just to show you? Okay, great. See if you can get an answer in the chat for me. So the range, if you want to find the range of this, you're actually looking not at the frequency numbers, because that's just how many people are receiving each amount of money. What you're looking at is the smallest and the biggest amount of money. So the range here, we wouldn't know the exact range because we don't know the exact smallest and the exact biggest. So again, it would just be an estimate of 25 minus 0. So it would be £25. So the range would be 25 there. Sorry, I didn't do range, did I? But hopefully that clears that up. Median, you wouldn't have to find the exact median because it's quite complicated. You can find the group which has the median in. So to find the group that has the median in, you need to find out how many people there are. There are 20 people. And then half of 20, or the median number, will be halfway between the 10th and the 11th. So if there's 7 in there and 6 in there, then the 10th and the 11th will both be in this group. So the median group would be that 5 to 10 group there. Okay, so that's range and that's median. And then mean remember that with the mean, you need to find the midpoint of each one. So it's quite often a good idea to put the midpoint as an extra bit on the table. I've not left much space here, but the midpoint, remember, is the middle of the group. So 0 plus 5 is 5, divided by 2 is £2.50. Here, 5 to 10, or halfway between 5 and 10, is £7.50, and so on. So you're finding the midpoint of each one. And then, yes, Meadow, correct. That is the correct answer for the mean. Well done. So then we know that 7 people received approximately £2.50. So we could say 7 times 2.5, or £2.50. Then we know that 6 people received approximately £7.50. 6 times £7.50. Plus, and we would keep going, we would say 3 people received approximately £12.50. 2 people, halfway between 15 and 20, is £17.50. So that's 2 times £17.50. And then the last one is 2 times halfway between that, 2 times £22.50. And then all of that, this is the bit that people tend to forget to do. Divide it all by the total frequency. So 7 plus 6 plus 3 plus 2 plus 2. So you end up with, I assume that top number is 180, divided by 20. And you get 9 for the mean, okay? So again, have a look. Does 9 fit within the data? Well, 9 is the estimated mean pocket money. So it's got to be within this range from 0 to 25. And yes, it is. It's fairly, not really in the middle, but more of the people are in the lower end anyway. So we would expect it to be a little bit closer to the lower end than the higher end. So it does seem about right. So well done. That's correct. I hope that makes sense. If you have any questions, do just pop them in the chat. The last thing on this I wanted to do was comparing distributions just very quickly, because it's a super easy thing, but people tend to lose marks on it. So I just want to kind of cover it quickly. If you're asked to compare distributions, so you might be given, I don't know, the time it takes children to do a puzzle, and then the time it takes adults to do the same puzzle. So you might be given like some data on how long children take and how long adults take. And then you might be asked to compare the distributions. There are always, it's very simple. You just answer in 2 ways. Okay. So you must compare, you must write something. Oh, right. Mouse is gone. There we go. You must write something about the average. Okay. So normally you might be given some information about a median or the mean or something like that. And then you must also write something about the spread or the variation of the distribution. So you'll be given either information about the range or the interquartile range. So an example of this, and if you can give numbers. So it might be that you're given raw data and you have to calculate the averages, in which case you get more marks. Or it might be that you're given a question that looks a bit like this. So we've got 20 students took a science test and a maths test. And both tests were marked out of 50. So they're the same, like they're marked out of the same thing. And here is information about their results. So all these students in their science, they got a median result of 27. And the interquartile range was 18. And in maths, they got a median result of 24.5 and an interquartile range of 11. And we're being asked to compare the science test results with the maths test results. You must write down 2 comparisons. So you must discuss both the median and the interquartile range. You must talk about those 2 things to get the 2 marks. So they're very specific about where the marks come from. So your first mark will come from talking about the median and what it means. So obviously they seem to have a higher median in science. So that means that they generally, on average, do better in science. So you might write down something like, the median for science is greater than the median for maths. So on average, the students did better in science than in maths. You don't need to worry too much about writing a perfect sentence. You just need to get that information down. So the median is higher for science, so students on average did better. So it's getting that word on average in, they did better in science than in maths. And then we also need to discuss, what does the interquartile range mean? While the interquartile range is also higher for science, but this doesn't necessarily mean students have done better. It actually means that there's a more variation in the results. So it means that while some students might have done really well, some students might have also done really badly. Whereas in maths, they were a bit closer together. So even though they didn't do as well, they were all kind of at a closer range. They got closer numbers or more similar marks, okay? So you might write something like, the interquartile range for science is greater than the interquartile range for maths. So the spread or variation of marks for science is greater than that in maths. So again, don't worry about how you write it, but just getting that information down, okay? So hopefully that makes sense. Okay. I'm not going to go through all of the statistical diagrams. I think that could be on both. That could be easily on a foundation or a higher paper, that kind of question. If you, on a higher paper, they might actually give you, like just the information for science, and maths might be in a table and you'd have to find your own median, or maths might be raw data. You'd have to find your own median and interquartile range. But generally for 2 marks, that could be easily on either higher or foundation. So good question though. Yeah. Okay. Statistical diagrams. So I'm just going to kind of list out what you need to make sure you can do. You need to make sure you're familiar with pie charts. So that's how to draw and how to use and interpret a pie chart, how to find the angle, things like that. Bar charts, I'm sure you kind of know how to use those. Pictograms, that reminds me of going all the way back to primary school pictograms. They very rarely come up on a GCSE paper. I think I've seen them like once. Two-way tables, something like this. This is quite often used in probability, where you'd have to fill in all the gaps here. So you just kind of look, okay, well, there's a total. This two-way table doesn't make sense at all because there's no way that 12 plus something can make 9. So that's a pretty bad one. But that's what they look like, and you just fill in the gaps there. Histograms, which I'm just about to go through in a bit more detail, and cumulative frequency diagrams as well. So the first 4, just kind of do go through them. I'm sure you've got plenty of resources you can have a look at if you're unsure. Histograms, I'm going to go through because they are kind of quite popular on GCSE papers. A histogram is a bit like a bar chart, but they can have different class sizes, different group sizes, which a bar chart cannot have. So you can see here, the group here, that's 100 to 120. This group is 120 to 140, but this group goes from 140 to 150. So whilst these 2 groups are like 20 apart, this one is only 10 apart. There's only a gap of 10, and there's only a gap of 10 here. And then we've got a huge gap of 40 here. So different group sizes is always a kind of a histogram thing, okay? And then we've got frequencies. So I don't know what this is height of, but 20, I don't know, let's say teenagers are between 100 and 120 centimeters. 25 are between 120 and 140, and so on, okay? So that's this data. Now, because of the fact that the group sizes change, we can't just go ahead and plot. We can't just plot this against this. If you could, histograms, you normally get 4 marks. If you could just do that, it wouldn't be worth 4 marks, okay? So you've got to think, where are these marks coming from? And 1 mark always comes from calculating frequency density, which is basically calculated by doing the frequency divided by the class width. And then we have a kind of more a proportion. It works out that the bar will be in proportion. So it will make more sense. It's actually the area of the bar that tells you the frequency. And we'll have a look at that in a minute. So to calculate the frequency density of the first group, we're going to take the frequency, that's 20, and divide it by the class width. So that's the gap from 100 to 120, which is 20. So our frequency density for our first one is 20 divided by 20, which is 1. So that first gap is 1 there. Frequency density for the next one is going to be 25 divided by this group, which is 20 as well. 140 minus 120 is 20. So that's 1.25. Frequency density for the next group, we've got 30 divided by only 10 this time. So always check the group sizes because they will change. 30 divided by 10 is 3. And then the next one, we've got 25 and a group size of 10, so 2.5. And then this time we've got a frequency of 20, but we've got this bigger group size of 40. So we've got a frequency density of 0.5, okay? So frequency density, really important when you're drawing a histogram, you must calculate that first. Don't forget about frequency density. If you just go ahead and plot this against this, you'll get 0 marks. And histograms tend to be worth 4 or 5 marks, okay? So really make sure that you do remember to get that, and then you plot that against this, okay? So the next thing you're going to do is you're going to plot the histogram. So your group 100 to 120, so that's here to here, is going to be plotted against the frequency density. So be careful, don't plot this. Frequency density is 1. And then the next one, 120 to 140 against 1.25, and so on. So you can see the bars are different sizes. Okay, so we've got like different width bars, but the area of each bar is proportional to the frequency. Okay, so this area is going to be 20 times 1, which is 20. And then this area of the next one is 20 times 1.25, which is 25. So that's how you work out the frequency for each one. Got a little fly. 5 here multiplied by 3. Oh, sorry, 10 here multiplied by 3, that gives us 30. So to find the frequencies, we're going to actually find the area of the bar. Hopefully that makes sense. Okay, so that was histograms. Does anyone have any questions on histograms? No. Okay, and we've got time to do cumulative frequency graphs, and then we'll push probability back to our next session because we've got a bit of space in next session anyway. So cumulative frequency graphs, though these ones are slightly different. Don't get histograms and cumulative frequency mixed up. Cumulative frequency, well, the word hopefully kind of sounds a bit like accumulate, I guess. We kind of accumulate the frequencies as we go on, okay? That's kind of how I get my students to remember this. So to calculate cumulative frequency, we're just going to add the frequencies up, okay? So we're going to go, okay, well, 8 plus 27 is 35. 8 plus 27 plus 21 is 56. And then we can add on this 16 and we get 72. Add on this 7 and we get 79. And add on this 1 and we get 80. And it's always important to check that this number matches the number that you have been told there are in total, okay? So the first thing you do with cumulative frequency is you add all those numbers up together, add the frequencies up. So these are now not representing, there's not 80 between 20 and 24. There's actually 80 between 0 and 24. Okay. So looking then at the drawing it, we are going to always plot cumulative frequency on the y-axis, on the vertical axis here. Okay. So that cumulative frequency should always go from 0 up to the total number. And the height should always go, or the time, or the width, or the length, or whatever it is down in this, should always go on this one here, okay? And then you're always going to plot the upper class boundary. So you're always plotting this number here, these numbers, okay? So you go to the highest number, 4, and then you plot that against the cumulative frequency, 8. And then you go to the next highest number, which is 8, and you plot that against the cumulative frequency, which is 35, and so on. So you're always plotting this upper class boundary against the cumulative frequency, and it should always go up. Your graph should always go up a little bit. It normally looks like this kind of slightly elongated S-shaped curve, okay? If your curve goes down, you've done something wrong. It should always go up because remember the numbers are adding them up each time. So it shouldn't go down at any point. If it does go down, you're probably plotting the frequencies and you need to go back and start again. All right. Then you must join it up as neatly as you can with a nice smooth curve that looks like this. Okay. So again, just look, check that it goes up, check that it ends at the top number. It should always end at the number that you've been told is the total. Okay. And there shouldn't be any sort of dips in it like that. So there would be a mistake there for cumulative frequency. Okay. So a quick list of all the things that we need to remember. Should have a title, should have nice, even, equal distances, no changes on the x-axis and the y-axis. Always put cumulative frequency on this one. Always put height or weight or time or length or whatever it is on there on the x-axis. And you quite often are asked to use your cumulative frequency graph to find a median or an interquartile range. So how do we do that? Well, to find the median, our total is 80. So our halfway point is going to be at 40. The median is going to be half, and it's going to be this. Always median comes from this side because this is how many, was it people or was it, I think it was tulips. This is how many tulips there are in total. So there are 80. So we're looking for the 40th tulip, and the height of the 40th tulip. You can read it by drawing a nice straight line from that 40 to the line, the graph, and then get your ruler and draw a line down to the height. So we know that our 40th tulip is about 9. I'd say it's a bit less than 9, but that's okay. As long as you show you're working clearly and you read it off as accurately as you can, it will be easier in the exam because you'll have a clearer sort of graph to read it off. You should get the marks there. You might get a slightly different mark to somebody else because theirs might look a little bit different to yours. But that's okay. You just have to make sure you show you're working clearly. If you find the lower quartile, hopefully you can remember from earlier that the lower quartile is 25% of the way through the data. So 25%, a quarter of 80 is 20. Again, if you're not sure, it's just half of the lower median part. So again, you're going to read a nice straight line along to the graph and down, and it looks like 6 there. Upper quartile is going to be the higher one. So that's going to come from 60, read it along to the graph, straight down, and halfway between 12 and 14, so that's 13. And then, of course, we did say we were going to find the interquartile range. Interquartile range, remember, is the upper quartile minus the lower quartile, which is 13 minus 6, which is 7. Okay, so that is cumulative frequency. Oh, and that's probability. I think we'll do probability next week because I've given you a lot of information today. We've got a couple of minutes left. Does anyone have any questions or anything? Oh, no. So good question. No. The question is, if we have to estimate the mean, do we also use the upper class boundary? No, with estimated mean, you would always use the method that I showed you before. So if you wanted to estimate the mean of this one, you would have to find the midpoint. Always use the midpoint. So we could do that quickly because we've got a few minutes. Let me go back to where the bigger table was. Okay, maybe I won't go back to the bigger table because it's not playing. There we go. Okay, so if we wanted to estimate the mean of this one, we would have to, even though it's cumulative frequency, we'd actually completely ignore all of this information, okay? The cumulative frequency is no good to us when we're estimating mean, so that's useless. What we would need to do is we would need to do the midpoint of this. So I'm going to pop it in there. I'm just going to squeeze it in. Sometimes just write it in anywhere. It doesn't really matter because you're working. So 2, halfway between 4 and 8 is 6. 8 and 12 is 10. Halfway between 12 and 16 is 14. Halfway between 16 and 20 is 18. Do shout at me if I'm making a mistake. I might well make a mistake. It's been a long day. So, okay. So I found the midpoint. So the first thing that you always do is you find the midpoints. That's your kind of first step. Then you do midpoint multiplied by frequency and you add it all up. Okay. So we're saying, well, 8 of the tulips are somewhere between 0 and 4, but we're going to say they're approximately 2. So 2 times 8 is equal to 16. 6 times 27 is equal to, it's getting dark, my calculator's 162. And then 10 times 21 is equal to 210. 14 times 16 is equal to 224. 18 times 7, 126. Oh, made a right mess there. 126. And 22 times 1 is 22. Okay, so we've done the midpoints. We've multiplied each midpoint by the frequency. And now we're going to find the total. Remember, mean is total divided by the number. So the total number of tulips, I guess, the total number of centimeters it's going to be, isn't it? Total number of centimeters. So we've got 16, we've got 8 that are 2, so that's 16. Plus we've got 27 that are 6, so that's 162. Plus 210. Plus 224 plus 126 plus 22. And we're going to divide all of that by the number. So the number of tulips is this frequency added up. So we know that the frequency added up is 80 because we did that earlier. Here we added it all up and got 80. So that is 80. And then calculating that, 16 plus 162, 224, 126. Do feel free to check that I'm doing this correctly. I'm getting, I just lost that number, 760. Seems too perfect, this divided by 80. Which is 19 or 9.5 centimeters. Okay, so that would be your estimate of the mean. So if you have to estimate the mean, Meadow, always go back to that method. You can literally show you're working like that. So show your midpoints, times it by each frequency and add them all up. Okay. Finally, just check. Okay, 9.5 centimeters it's the mean height of the tulips. So the smallest height is 0, the biggest height is 24. So yes, 9.5 fits quite nicely in that data. It's a little bit less than halfway, but again, more of the numbers, the bigger numbers are lower down. So you'd expect it to be slightly smaller than halfway. Okay. And that, I think, brings us almost to the end. So yeah, we've done lots on, we've done the whole statistics module today. Very quickly, and I apologize for that, but do go away and just kind of digest it all and have a go at doing some of these some of these problems for yourself and some exam style questions for yourself. And does anyone have any questions for me? Let me stop sharing.